right, now we're going to work an electrolysis cell. Remember, this is a non-spontaneous cell. This is different than a galvanic or a voltaic, which are spontaneous. And so this is going in reverse. So what we're going to do is start off with writing the reactions that occur at the anode and the cathode and label them. Okay, so let's start with our very basic, which means that if we're dealing with tungsten 6 nitride, the Roman numeral means that it's a 6 plus, so we know that we're going to get tungsten 6 plus 2 nitrides, which are 3 minus. So we know that those are the ions that we're going to work with. So we'll start with the tungsten, which is 6 plus, which is going to gain 6 electrons to produce the tungsten metal. Now remember, this is reduction, so this still occurs at the cathode. Okay, you weren't asked to label anode reduction and oxidation, but it makes it easier. Remember that reduction still occurs at the cathode, but now instead of cathode being positive, since the reaction is force negative, the sign, if you were to do it, would be negative. Alright, so the sign is negative. Alright, you don't have to put that in. We have 2 nitrogen ions. I'm going to keep the arrow to line up. Now what we'll produce is the diatomic nitrogen, and we'll give off 6 electrons. So again, this is the anode, because this is where oxidation is going on. Since you reverse the sign, this is for the non-spontaneous cell. Obviously, I can't spell, so this is non-spontaneous. Okay, so that's the first half of the reaction. Now, before we do the second part, which is part B, let's do a little refresher on some of our units that we're going to need. We're starting with grams, and we're going to need to go to moles, so we're going to need atomic weight. Alright, we've got to remember that Faraday's constant is equal to the number of coulombs, 96,485 coulombs per 1 mole of electrons. Okay, why do we need that? Because remember, an amp is going to be equal to coulombs per second, and we're asked to do hours, so just out of sheer meanness, remember that 1 hour is equal to 3,600 seconds. Now, the amp unit is given on my equation sheet, the Faraday constant is given, and the atomic weight is found on the periodic table. So I usually start with what we're looking for, which is hours, and we're going to start with our amount. The only amount we're given is 22.1 grams of the tungsten. At this point in time, we go to our periodic table. We find out that it's 183.84 grams of tungsten per 1 mole of tungsten. And again, our units are going to cancel. We know that we need 1 mole of tungsten down here, so we're going to get to moles of electrons. Okay, again, we're canceling our units. 1 mole of electrons goes in the bottom, and Faraday's constant goes in the top, which is coulombs. So we know that coulombs will go on the bottom. Well, we have coulombs as the amperage, so 1.88 coulombs is 1 second. That's the amperage. Remember, it's like density. The unit stays with coulombs. And we know that there are 3,600 seconds in 1 hour. So we're going to do the math, and remember, anything on top is multiplied, anything on the bottom is divided, and we end up with 10.2826. So that means that we have 10.2826 hours are needed to plate out 22.1 grams of the tungsten metal.